Here in this code we can see, and let's ignore first this part. Let's ignore first this part. First come let the main motive for this code is that I have written here a Fibonacci function which shows a Fibonacci series. Fibonacci series is what? A Fibonacci series is Fibonacci series. Fibonacci series is a sequence of numbers where each number is the sum of two preceding ones starting with 0 and 1. It's represented as like this. 0 first we start with give two numbers 0 and 1. And third number will be 0 plus 1 1. And then next number will be 1 plus 1 2. And then next number will be 2 plus 1 3. Then 3 plus 2 5. 5 plus 3 8. And the result that comes and result minus 1 that comes will be the next result. So this like this the Fibonacci series goes on. So if I say I want the Fibonacci series 10th term, what is the 10th term? 0, 1, 2, 3, 4, 5, 6, 7, 8. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. This is ninth term. Ninth term is 34. So let's say I make it here Fibonacci series. This is the simplest Fibonacci formula without any modification, without any like modifications and other things, other add-ins. It is the simplest Fibonacci formula. So let's say I calculate here ninth term. I calculate here. This is 38 term. This calculator. I calculate ninth term. So it should come 38. It's come 34. Yes, correct. Here it is 34. Where it went. 34. See, ninth term is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth term is 34. So like this we calculate the particular nth term of the Fibonacci series. So where does this Fibonacci series comes as used in? Fibonacci series applications application real life what is it used for? And cryptography techniques stemming from the Fibonacci sequence can be useful in creating secure cryptographic algorithms. For example, Fibonacci-like sequence can be used to generate random numbers, create sequences for hashing or just to. This is technical term, but I think application in sunflower natural. Sunflowers naturally exhibit the Fibonacci sequence in the arrangement of their seeds. Counting the spirals of seed in opposite direction, clockwise and counterclockwise, often reveals number from the Fibonacci sequence. Like here we can see the sequence has been shown in seeds. This pattern is believed to optimize the packing of seeds within the sunflower head, allowing it for more efficient use of space. Like this here we can see it is 1 and here it becomes 2, here it becomes 5. Something this pattern has been shown. Fibonacci numbers of sunflower seed spirals. It has shown the spirals here. This you can refer to YouTube how this is natural phenomena in sunflower. This Fibonacci series like this, the series as it is here. And this natural phenomena of Fibonacci series is also used in cryptography for security of computers on internet. So here now let's come to the code part. Here I will explain this code. This timer decorator is a function which I have written here. This code timer decorator, and then I have written this main function Fibonacci function. I have written here. These two are the main parts. You can delete this here. It's not required. This is the Fibonacci function I have written here. Then I have combined this decorator and this Fibonacci function using this line. Then this is my function. After combining this my function timed FIAB, when I pass the parameter 9 in it and got the values of result and execution time for it in these variables. So I printed the result and the execution time. So I got this. Now suppose I want it for 35. I want it for 35. Fibonacci series of 35th term. Now let's run it. It has taken. This is the result of your 35th term of the Fibonacci series. 35th term will be this 35th term, and time is 2.02005 seconds to execute this code. But now let's see in this memoization code. This is the same Fibonacci formula. Instead, I have used a memo variable here, a dictionary, and I have used this part of the code. These are the change in part of the code. These three that I have replaced it with. Now, by using this memoization technique in this code, I can run this code very fast. Like if I will run Fibonacci 300th term, then it will take 0.00129 seconds and it will give me this result. 300th term of the Fibonacci series will be this. And if I run it here like 35 as I ran it before that in this code, so it will give me in 0.00012 seconds. Let's in 12 micron seconds. 12 micron seconds it will give me this result. But here it is taking 2 seconds to give this result. 35th term. This is the fast calculation is because of the memoization technique that I have used here. That is a phenomena of Python programming language, a technique in Python programming language to calculate the fast recursions. Where the recursion is used in code in Python, then the computer calculation becomes slow. So there we can use memoization to optimize and make the process fast to calculate. It is something like a, we can say it very clearly, we can say it as it is something type of caching in Python. Like we can say it, memo is like, or memoization is like caching in Python. Like in computer we use cache, in internet we use cache. It is like caching in Python. Caching in Python. So we can, when I run it here, like suppose I run here 300, it will give me in seconds. Like in this 200 micron seconds, it gave me this result. But when I will run here, like here I will run suppose 50, it will take a lot of time. 300 is very far away. No, we cannot talk about this here in this code. So it will take infinite time. The server will not calculate it. It will crash. The Python code will crash. So here let's calculate for 50. I have run the code for 50. It is running here. And see, till now also it has not calculated it, not given the result. Now let's see how much time it will take. I think it will take around 1 minute. 1 minute it will take around to calculate the 50th term. But here we calculated the 300th term in 0.0000210 seconds. But here it is taking too much time as compared to this. It is not given yet. I think it will take very much time. So let's calculate for 38, for example. 38. Let's copy it, reload it, paste it, and do for 38. I think it will take around 8 to 10 seconds to calculate this. It has taken 9.401377 seconds to calculate this. But here when I will run 38, it will take 0.00001 seconds, like say 0.00020 seconds it has taken here, and here it has taken 9 seconds. This is the power of memoization or caching in Python. This is can be a demonstration or working model of caching in computers. So if you are supposed to make a working model of caching in computer, you can demonstrate the caching using this Python code. How the caching works in our computers, in PCs, in our hardwares, in our machines, in our washing machines, in our TVs, in our Android phones, in our websites, in our internet. How the caching works, you can demonstrate using this. How caching makes the computer very fast. Like in modern computers, the caching memory that comes is around in ordinary laptops in range of 40 to 50,000, it comes around 4 MB, and even a single 1 MB caching power can make the computer very fast. So but in modern laptops it comes around 4 MB, or in very advanced laptops it comes around 12 MB, like in very expensive lakhs of rupees of laptops. So like this we can improve the performance using caching or memoization in Python. Thank you.